Imagine looking up at the night sky, a canvas of serene, twinkling lights. It feels peaceful, almost eternal. But what if that same sky held a secret, a weapon of cosmic proportions, capable of wiping out life across an entire galaxy in a literal flash? This isn't science fiction. We're talking about gamma-ray bursts, or GRBs, the most powerful explosions known in the universe. To understand their power, let's start with what they are. A gamma-ray burst is an incredibly intense, narrow beam of electromagnetic radiation. These bursts are born from some of the most cataclysmic events in the cosmos. One common cause is a hypernova, the collapse of a massive star many times larger than our own sun at the end of its life. Another cause is the collision of two neutron stars, the ultra-dense remnants of dead stars. When these celestial titans spiral into each other and merge, the resulting explosion unleashes a torrent of energy. Just how much energy are we talking about? A typical gamma-ray burst releases more energy in a few seconds than our sun will produce in its entire 10 billion year lifetime. It's a number so vast, it's difficult for the human mind to truly comprehend. Think of all the energy from our star, for billions of years, concentrated into a single fleeting moment. This energy is not released in all directions like a normal explosion. Instead, it's focused into two narrow jets, shooting out from the poles of the collapsing star or merging objects. These jets travel at nearly the speed of light, like cosmic laser beams piercing through space. If you're in the path of one of these jets, the consequences are devastating. Now, let's bring this threat closer to home. What would happen if a gamma-ray burst were to strike Earth? The good news is that gamma rays themselves wouldn't reach the surface. Our atmosphere is a surprisingly effective shield. The bad news is that the interaction with our atmosphere would trigger a series of catastrophic chemical reactions. The immense energy would hit the upper atmosphere, specifically the nitrogen and oxygen molecules. This collision would tear apart these molecules, breaking the strong bonds that hold them together. The nitrogen would then react with oxygen to form nitrogen oxides in massive quantities. This would create a thick, reddish-brown smog of nitrogen dioxide that would envelop the entire planet, blocking out a significant portion of sunlight. Photosynthesis, the foundation of nearly all life on Earth, would grind to a halt. Plants and phytoplankton in the oceans would perish on a global scale. This would cause a complete collapse of the food chain, leading to mass extinction for countless species that depend on these producers. But the destruction doesn't stop there. Those newly formed nitrogen oxides would wreak havoc on our planet's protective ozone layer. Scientific models suggest that a gamma-ray burst from a few thousand light-years away could deplete the ozone layer by as much as 75% globally. In the regions directly facing the burst, the destruction could be almost total. Without the ozone layer, the Earth's surface would be bombarded by a deadly flood of ultraviolet radiation from our own sun. This UV radiation would be lethal to most life forms that survived the initial darkness. It would cause severe damage to the DNA of any remaining organisms, leading to widespread death and an inability to reproduce. The planet would be effectively sterilized. The nitrogen oxides would also mix with water vapor in the atmosphere to form nitric acid. This would fall back to the surface as a highly corrosive acid rain. This acid rain would poison the soil, contaminate rivers, lakes, and oceans, and make the surface of the planet even more inhospitable for any struggling survivors. It would be a multi-stage global catastrophe. First darkness and a collapse of the food web, followed by a lethal bath of UV radiation and a downpour of acid rain. The chances of complex life surviving such an event are incredibly slim. Some scientists even speculate that a gamma-ray burst may have been responsible for one of Earth's past mass extinctions. The Ordovician-Silurian extinction event, which occurred about 450 million years ago, saw the demise of around 85% of all marine species. The pattern of this extinction has some characteristics consistent with a GRB event. Researchers have pointed out that the extinction seems to have happened in two distinct pulses, which could align with the initial effects of a GRB and the subsequent ozone depletion. While it's just a hypothesis, it's a chilling reminder that this might not be just a future threat, but a past reality. So, what are the odds of this happening? The galaxy is a vast place, and GRBs are relatively rare. Most GRBs we detect come from distant galaxies, billions of light years away. They are far too distant to pose any threat to us. For a GRB to be dangerous, it needs to happen